Yeah, so very good afternoon to all of you. So today also we are going to discuss about the redox reactions lesson, right? So yesterday we have completed till the special cases and we have done some things, okay, some definitions like oxidizing agents, reducing agents, etc. So today we are going to enter into a new topic called types of redox reactions. Okay, types of redox reaction. So under this topic, the learning objectives are, we are going to study 4 types of reaction. The very first is combination reaction. The second is decomposition reaction. Third is displacement reaction. And the fourth type is disproportionation reaction. Okay. So these are the 4 types of reactions we are going to discuss in today's class. Okay. So now let's start with the first. Let's start from combination reaction. So what is a combination reaction? So combination reaction may be denoted as A plus B giving C. So if A and B combines with each other to form C, then we call those reactions as combination reaction. Okay. So we are taking 2 reactants, right? A and B. So among this A and B, either one of the reactant must be in the elemental form. That is the condition. Okay. Either one must be in the elemental form. Elemental form means uncombined state. So uncombined in the sense, not only that, like magnesium, aluminum in the atomic form. Also we can have H2, Cl2, O2, N2. So they are also called as elements only. Okay. So one should be in the elemental form. Okay. So what are the reactions will come under this combination reaction type? The very first is combustion reaction. So all combustion reactions will fall under combination category. Okay. So I will give you an example. So here you see carbon is reacting with oxygen to give carbon dioxide. And since carbon and oxygen in the reactant side are present in their elemental form, they are taking the oxidation number of 0. Okay. And then coming to carbon dioxide. So here, if I take carbon as X and for each oxygen -2, so 2 into -2 is -4, 0. So it will be +4. So the carbon oxidation state is +4 and the oxygen oxidation state is -2. So what is meant by combustion reaction? Heating a compound in presence of sufficient supply of oxygen is called as combustion reaction. Okay. So here carbon is getting oxidized and oxygen is getting reduced. So this is an example for combination reaction. Okay. Next, coming to one more example. Combustion of methane. CH4 is called as methane. Okay. And the oxidation state is given for all the elements. And if you look into the oxidation state of carbon, it is moving from -4 to +4. Means it is oxidation. Okay. And the oxygen is moving from 0 to -2 in both the cases. So it is reduction. So it is an example for redox reaction. Okay. So here in both the cases, we are using oxygen and this oxygen, okay, reacts with carbon and methane to give the corresponding products. Okay. So which makes use of elemental dioxygen or redox reactions. The combustion reactions which use oxygen as one of the reactant are called as redox reaction. Okay, so oxygen is present in the elemental form in case of combustion reaction here. Okay, carbon is an element, but methane is not an element. It is a compound. Okay, so oxygen is acting as an element in both the cases. Clear for all of you? Any doubt? Do you have any doubt from the 2 examples given here? Can you all able to understand why these 2 reactions are called as redox reactions? Because both oxidation and reduction takes place. Okay. So I will give you some other reactions, Okay. Some other means some other examples for combination reaction. Okay. So here you see, magnesium is reacting with nitrogen to form Mg3N2. So here we are not using oxygen, so it will not come under combustion. It will come under other reactions. Okay, so magnesium is in zero oxidation state and nitrogen is also in its zero oxidation state because both of them are elements. And when they combine to form the product, the oxidation state attained by magnesium is +2 and for nitrogen it is -3. So all of you can able to understand why it is taking -3 and +2, right? So Mg3N2. So we have 3 magnesium, so it is 3x and the valency of nitrogen is 3. So it will take -3 charge. For oxygen, we are giving -2, right? So in the same way for nitrogen, we have to give -3 if it is present in its compound form. Okay, if it is an element, then you have to give 0. Okay, so we have 2 nitrogen. So 2 into -3 will be there. So 2 into -3 is nothing but -6. Okay, which is equal to 0. And 3x is 6 and x is equal to +2. So this is how we are getting the oxidation state of magnesium as +2. Okay. So magnesium is moving from 0 to +2, which is an oxidation. And nitrogen is moving from 0 to -3, which is a reduction. So it is also an example for redox combination reaction. Is it clear to all of you? So both magnesium and nitrogen are the elements in this reaction. Any doubt from combination? Shall we go for the next type of reaction? Students, let me know your answer in the chat box. Is it clear? Or do you have any doubt? Is it clear to all of you? Do you have any doubts? Rohit, Sandhya, Shimoga, Likita. So guys, tell me the answer in the chat box. Everything clear? Any doubt? You can give your answers in the chat box. Why are you feeling so scared? I don't know, guys. Okay, thank you, Meenakshi, for your response. So now, okay. So now let's enter into the next type of reaction, which is called as decomposition reaction. Decomposition is the opposite of combination reaction. Okay, decomposition reaction is the opposite of combination reaction. So what is the definition? What is meant by decomposition reaction? It is the breakdown of a compound into 2 or more components. Okay, breaking one compound into 2 or more components is called as decomposition. Okay, so among the components, one of them must be in the elemental state. Okay, so I will give you an example. So 2H2O on heating gives 2H2 plus O2. Okay, so here one compound, water, is breaking down into 2 components. One is hydrogen and the other one is oxygen. So here in this case, hydrogen and oxygen, both of them are elements only. Okay, so the condition is at least one of them must be in the elemental state. Okay, for this example, both of them are elements only. All right. So here who is getting oxidized and who is getting reduced? What about hydrogen? Hydrogen is moving from +1 to 0. +1 to 0. +1 to 0 means it is oxidation or reduction. Can anyone tell me? +1 to 0 means oxidation or reduction. +1 to 0 means it is oxidation or reduction. Hey, everybody is keeping quiet. +1 to 0. Just look into the number line. So in the number line, plus 1, plus 2, minus 1, minus 2, right? Plus 1 to 0. It is moving towards left side. So it is reduction. Very good, Pragati. It is reduction. So what about this one? Minus 2 to 0. Oxygen is moving from minus 1, minus 2 to 0. Minus 2 to 0. So it is moving towards right side. So it is oxidation. Okay, it is oxidation. Clear? So it is an example for redox reaction. Got it? So now let's go for one more example where sodium hydride on heating gives sodium and hydrogen. So here the oxidation state of sodium is plus 1. We all know that because it is an alkali metal. Sodium is an alkali metal, right? And when hydrogen is bonded to a metal, it will take minus 1 charge. So that's why hydrogen is taking minus 1 here. So this is also, you all know. And it is moving from, sodium is moving from plus 1 to 0 state and hydrogen is moving from minus 1 to 0 state. So plus 1 to 0 means it is reduction. Minus 1 to 0 means it is oxidation. Okay. So for the second example also, we are getting elements, sodium and hydrogen. Both of them are elements only. All right. So let us go for one more example. Where 2 KClO3 on heating gives 2 KCl plus 3 O2. Let us go for the oxidation state of each element in this compound. Okay. So let me take KClO3. So we all know that potassium is an alkali metal. So it takes plus 1 charge. Okay. And oxygen takes minus 2. So using these two numbers, you can find out the oxidation state of chlorine, right? So take chlorine as X. For potassium, it is plus 1 plus X. 3 into minus 2 is minus 6, which is equal to 0. So X is equal to 6 minus 1. It will be equal to plus 5. Okay. So plus 5 oxidation state containing chlorine is getting converted into minus 1 state. So tell me whether chlorine has undergone oxidation or reduction. Plus 5 to minus 1. Plus 5 to minus 1. Is it oxidation or reduction? Plus 5 to minus 1. Very good. It is a reduction. Very good, students. It is reduction. Now, oxygen is moving from minus 2 to 0. So it is oxidation. So it is an example for redox reaction. Okay. So one compound is breaking down into 2 or more than 2 are called as decomposition reactions. Clear? Any doubt from this? Do you have any doubt? From this, from these 3 examples of decomposition. So I have one more thing to tell you about decomposition that I will discuss in the next slide. So everything is clear so far, right? Okay, very good, Sandhya. Now let's go for one more point which is very important for decomposition reaction. All right. The point is, all decomposition reactions are not redox reactions. All decomposition reactions are not redox reactions. The example is calcium carbonate on heating gives calcium oxide and carbon dioxide. So here if you look into the oxidation number of each element, you will get like this. This is very easy to, because calcium, if you take calcium carbonate, calcium belongs to second group, alkaline earth metal group. Okay. So second group means oxidation number will be plus 2. For first group alkali metals, we are giving plus 1, right? So in the same way, for second group, we have to give plus 2. And for oxygen, we know it is minus 2. So using this, you can calculate. So plus 2 plus x minus 6 is equal to 0. So x is equal to 6 minus 2, which is equal to plus 4. So this is how we are getting the oxidation state of carbon as plus 4. Okay. And here also the same way, plus 2 minus 2. And carbon dioxide, you know how to calculate, right? So here if you see, the calcium oxidation state remains same. In the reactant side also it is +2. In the product side also it is +2. If you look into the oxidation state of carbon, the reactant side also +4, product side also +4. And for oxygen, -2 and -2. So the oxidation number for all the elements in the reactant side as well as in the product side remains same. Okay, so it has not undergone oxidation, neither reduction. Clear? So this is not an example for redox reaction, but it is an example for decomposition because one compound is breaking down into two, right? So it will come under decomposition, but it is not a redox reaction. Is it clear to all of you? Is it clear to all of you? Calcium remains same. There is no change in oxidation number. Carbon also remains same. So there is no change in oxidation number. So it is a very good example for the given statement. Okay. So you can get question like this. I mean, in 4 options, out of 4 options, they can give you the redox reaction in 3 options and they can give you this particular reaction in the 4th option. And they will ask you to find out which among the following is not a redox reaction. Okay. So you can keep this example in your mind, or you have to calculate the oxidation number of each element given in all the reactions and you can get the answer. Okay. Clear? So this is all about the decomposition. Yeah. So now let's enter into the displacement reaction. What is meant by displacement? An ion or an atom in a compound is replaced by an ion or an atom of another element. Okay. So one atom or ion is getting replaced with another atom or ion. So that is called as displacement, moving from one place to another. Okay. So let me give you the representation. When X is reacting with YZ, X and Y will replace. Okay, X will replace Y and it will form XZ and Y. So what has happened here? One element has displaced the other element. Okay, this type of reaction is displacement. There are two types of displacement reaction. One is called as metal displacement and the other one is called as non-metal displacement reaction. Okay, so let us first discuss about the metal displacement and then we will move on to non-metal displacement. All right. So can you all able to understand what is displacement reaction? So no doubt in the definition of displacement reaction, right? Shall I start with the metal displacement? Shall we go ahead? Any doubt so far? Okay. Great. Great. All right. So let me start with the metal displacement. So what is metal displacement? A metal in a compound can be displaced by another metal in the uncombined state. This is displaced. Okay, sorry for the typographical error. So a metal in a compound can be displaced by another metal in the uncombined state. So those are called as metal displacement. So this particular type of reaction finds many application in the purification of metal process. Okay, so let me give you one example among that. So when copper sulfate is treated with zinc, it forms a pure copper and zinc sulfate. Okay, so copper sulfate is getting purified from the copper sulfate. Copper is getting purified from copper sulfate. So it finds many application in the purification of metal. So all of you can able to see the oxidation state, right? So copper is +2, sulfur +6, oxygen -2. And here zinc is in its elemental form 0, copper is also in its 0 state. And here when you come zinc +2, sulfur +6, oxygen minus 2. So all of you can get the oxidation state given for each element, right? You want me to calculate for any compound? Or do you know how to calculate the oxidation state of each element in a compound? You want me to teach anything? The calculation for finding out the oxidation number of any element in a compound. If you want me to teach, just tell me the compound that you want me to teach. I will take that compound and I will explain you. Do you have any difficulty in finding out the oxidation state of element in compound, in copper sulfate or in zinc sulfate, students? You want me to teach zinc sulfate? Okay. Listen, zinc sulfate. So zinc mainly takes +2 oxidation state. You can ask me, ma'am, how do I know that zinc will take +2 state and all? Okay. When you complete your 12th standard, you will come to know how zinc is taking +2 state, because the only oxidation state exhibited by zinc is +2. Okay, so those information you will study in your class 12. Okay, so I'm not going for that now. So you can keep zinc as X for now, because you don't know, right? So you can keep zinc as X for now. And coming to sulfur, sulfur belongs to oxygen group. Sulfur belongs to oxygen group. So the maximum oxidation state or the number of valence electrons of sulfur is 6. Okay, so you can put +6. And for each oxygen, the charge is -2. So it is -8 here, which is equal to 0. So X is equal to 8 minus 6. So it will come out to be +2. So this is one way. Okay. Or you should know that SO4, which is a sulfate, will take 2 minus charge. In case of H2SO4, we are putting, right? In case of H2SO4, we are telling, no, SO4 2 minus and 2H plus. So in the same way, if you see sulfate anywhere, it will take -2 charge. It is very well known for many people, right? So according to that charge, you can decide the charge of zinc, which is +2. Okay, zinc 2 plus and SO4 together 2 minus. And if you want to find out the oxidation state of sulfur, from this you can calculate. Keep sulfur as X. So 4 into -2 is -8. And since it has 2 minus charge, it has gained 2 electrons. So +2 is equal to 0 and 8 minus 2 is +6. Okay, so this is one way to calculate the oxidation state of sulfur. So the thing is, sulfate will always carry -2 charge. Sulfate will always carry -2 charge. So using that, you can get the answer. Okay. So if you get used to this and if you get practiced, then it will be easy. You don't have to find these things as difficult one. Okay. Clear? Who asked me? J and V. I don't know the name of this the student. Is it clear? Okay. So this is how you have to calculate for copper sulfate also. SO4 2 minus. So copper will take 2 plus. Now here, if you see, copper is moving from +2 to 0. Copper is moving from +2 to 0. So what it is? Is it oxidation or it is reduction? +2 to 0. Yes, very good, Meenakshi. It is reduction, right? So copper has reduced. Copper has got reduced. Okay. Next, if you see to the zinc oxidation state, zinc is moving from 0 to +2. 0 to +2 means it is oxidation. So zinc has got oxidized and copper has got reduced. Okay. So it is an example for redox reaction. So one metal is displacing the another metal. So which metal is displacing? Zinc metal is displacing the copper metal. So it is an example for metal displacement. Okay. So let's see one more example. Cr2O3 reacting with aluminium to form Al2O3 and Cr. Okay. So chromium. Chromium is a metal. Aluminium is also a metal. So what this aluminium is doing? Aluminium is displacing chromium. It is an example for metal displacement. Okay, so if you want to find out the oxidation state of chromium here, so we have 2 chromium, so it will be 2x, and 3 into minus 2 is minus 6. So 2x will be 6 and x is equal to plus 3. Okay, plus 3. So in the same way, for aluminium also you have to calculate in the same way and you will get plus 3. All right. So now coming to the oxidation state of chromium, chromium is moving from plus 3 to 0. Plus 3 to 0 means it is reduction. Chromium has got reduced. Then if you look into the oxidation state of aluminium, it is moving from 0 to plus 3. 0 to plus 3. So it is oxidation, which is an example for metal displacement. Okay. So is it clear for all of you? So if one metal is displacing the other metal and if they are undergoing the change in their oxidation state, it is an example for metal displacement redox reaction. Okay, one metal will be reduced and the other one will get oxidized. Okay, shall we go for the next concept? Any doubt in finding out the oxidation state for any element? Okay. So now the next topic is metal activity series. This is one of the small topic which comes after this metal displacement. Okay, so what is metal activity series? All the metals are arranged in the order from most reactive to least reactive. Okay, so if they are arranged in the increasing or decreasing order of I mean in the order, then it is called as metal activity series. Okay, in the increasing order of reactivity, or if they are arranged in the decreasing order of their reactivity, we call it as a series, and those series are called as metal activity series. All right. So here if you take 3 elements. Let me take 3 elements. First one is zinc. Second one is copper. Third one is silver. Can anyone guess why I have taken these 3 elements? Can anyone guess why I have taken these 3 elements? Let me see who remembers the concept which we have studied in the first class of redox reaction. Can anyone guess why I have taken these 3 elements? In which concept we have come across these 3 elements in this lesson? Under what topic we have discussed? Do you guys remember? No, they don't belong to same group, my dear. Do you guys remember the electron transfer reactions? Under the topic competitive electron transfer, we have studied 2 experiments. Do you guys remember? In the first experiment, we took a beaker and the copper sulfate was present inside it and the zinc rod was placed inside the solution. Do you guys remember that? Yeah, very good. So in that experiment, we have discussed about these 3 metals. Okay. And also I told that zinc is more reactive compared to copper and copper is more reactive compared to silver. So do you guys remember this order which I gave you in that class? I also told that zinc is more reactive and that's why it is able to displace copper from the solution. Okay, and copper is more reactive and that's why it is displacing the silver from the solution. So that is because of this reason only. There we have studied this in the name of electrochemical series, and electrochemical series are otherwise called as metal activity series. So these are the other names. So zinc is more reactive than copper. Copper is more reactive than silver. Okay. So zinc can replace copper, but copper cannot replace zinc. Zinc can replace copper. Copper cannot replace zinc. Okay. So let me take some more examples. Let me take potassium and calcium. So potassium can replace calcium, but calcium cannot replace potassium. The reason is potassium is more reactive and calcium is least reactive. So a most reactive metal only can displace a least reactive metal. Is it clear to all of you? So in the previous example also, in the previous slide also, you see zinc is displacing the copper. So in the product, if you see, zinc is displacing the copper because zinc is more reactive than copper. Okay. So if I would have taken zinc sulfate and if I make this to react with copper, do you think the reaction will happen here? Do you think the reaction will occur? Can you tell that copper sulfate will form and the zinc will go out? No. So the reaction will not occur because copper is not having the capability to displace zinc as it is very less reactive. Okay. So that's why I have brought this metal activity series for you. And the second example also you see, aluminium can able to displace chromium because aluminium is more reactive than chromium. So in the metal activity series you see, aluminium is here and chromium will be below this. Chromium will be below this. So since aluminium is more reactive than chromium, chromium is a D block metal. It will come here. Okay. All D block metals will come in the least reactive part. So chromium is least reactive and aluminium is more reactive. So that's why aluminium can able to displace chromium, but chromium cannot displace aluminium. All right. So such series are called as metal activity series. Can you able to understand? So you don't have to memorize this list. You can keep in your mind that in most cases, the alkali metals and alkaline earth metals are more reactive. That is, the elements which are present in the left side of the periodic table are more reactive. Okay. So potassium, sodium, calcium, magnesium. So all these are S block elements, right? So those elements are highly reactive in nature. And aluminium, carbon, if you see, they belong to P block. Okay. Then zinc, iron, tin, lead. Okay. So D block and P block will combine and it will come like this. So the very important order that you have to keep in mind is zinc, copper, and silver. Okay. Clear. Shall I go for the non-metal displacement? Any doubt in the metal activity series and metal displacement reaction? Shall we start with the non-metal? Okay. Okay. So non-metal displacement includes hydrogen displacement and a rarely occurring reaction involving oxygen displacement. Okay. So mostly hydrogen will get displaced. In some cases, oxygen will get displaced by the other element. So those are called as non-metal displacement reaction. Okay. So let us go for one example. Sodium is reacting with H2O to form sodium hydroxide and hydrogen. So what is happening here? Sodium is a metal. Okay. And hydrogen is a non-metal. So in the product side, hydrogen is getting displaced by sodium. So I can write water as H plus and OH minus, right? So this is sodium, and this is hydrogen, H plus. So here we are getting sodium hydroxide. So sodium is displacing hydrogen. Okay, and H2 gases evolved out. So it is an example for non-metal displacement. Okay, the oxidation state of hydrogen, you see. So oxidation state of hydrogen is changing from +1 to 0. It is changing from +1 to 0. So it is actually reduction. Hydrogen is undergoing reduction in this case. And if you look into the sodium, it is moving from 0 to +1. So it is oxidation. So sodium is undergoing oxidation and hydrogen is undergoing reduction. Got it? So let me show you one picture. So this is the picture which corresponds to this reaction. So I have a container and water inside it. So if I put the sodium metal, all of you can able to see the sodium block, right? So this is a sodium metallic block. If I put the sodium inside this water, what is happening? What is happening? You can able to see the fire, right? So it is exothermic reaction. It is highly exothermic in nature. Okay, it is highly exothermic in nature. The hydrogen gas is coming out and all of you can able to see the fire over there. Okay, more amount of energy will be released from this reaction. So now let's go for one more reaction where F2 is reacting with the H2O to form HF and O2. And here also hydrogen is getting replaced by or displaced by fluorine. This is getting displaced by fluorine. So oxygen is going from -2 to 0, which is oxidation, and fluorine is going from 0 to -1, which is reduction. Okay. So all alkali metals and some alkaline earth metals like calcium, strontium, and barium will displace hydrogen from cold water. It will displace hydrogen from cold water. All alkali metal means group 1. Okay. So who are group 1? Lithium, sodium, potassium, rubidium, and cesium. So all these 5 alkali metals can be displaced. Okay, one among the example. One among the element is given here as an example. And some alkaline metal. So what are alkaline metal? Alkaline earth metal means we will start with beryllium, magnesium, calcium, strontium, and barium. Okay. So these are the uh, first 5 alkaline earth metals. First 5 alkaline earth metals. But beryllium and magnesium will not come in this list. Okay. It will not come in this list. Why not hot water? Yeah, it is because the reaction will go highly exothermic in nature. It will get burst out. So that's why we have to do the reaction in cold water. Okay, already we can able to see the fire, right? So if you do this in hot water, your container will get burst out. That's why. Clear? Clear? Okay. So out of these 5, you have to remove beryllium and magnesium and you have to take calcium, strontium, barium alone. So let me show you one reaction, okay, for calcium. So when calcium is treated with water, it forms calcium hydroxide and hydrogen. Where calcium is getting oxidized and oxygen in 2 minus form gets reduced. Not oxygen, hydrogen. Hydrogen from +1 state, it is going to 0 state. Okay, from +1 to 0. So +1 to 0 means it is a reduction, right? 0 to +2 means calcium oxidation. It is an example for redox reaction which will come under non-metal displacement. So in all the 3 examples that you can see on the screen, in all the 3, hydrogen is getting displaced by the other element. The other elements are sodium, fluorine, and calcium. Okay. So now moving ahead with the non-metal displacement, the less reactive metals such as magnesium and iron react with the steam to produce the hydrogen gas. React with the steam to produce the hydrogen gas. What is the difference between the previous reaction and this statement? So in the previous reaction, you see, in all the cases, H2O is present in its liquid form. H2O is present in its liquid form, right? It is present in its liquid state. So all these elements can react with water in its liquid form. But the very less reactive elements like magnesium and iron react with the steam. Steam means H2O in gaseous form. So you can able to see, right? H2O present in its gaseous form is called as steam. So magnesium can react with water in its gaseous form to form magnesium hydroxide and hydrogen gas. Okay, the same way iron. Iron with H2O in gaseous state can be oxidized to iron oxide and hydrogen. They will use an apparatus like this for the production of this hydrogen gas. Okay, so we have a burner here and we have a container like test tube kind of thing in which the metal sample is present and glass will soaked in water is present here. And if you heat it, the reaction will occur, and using this tube, okay, using this delivery tube, the components will come and we have some of the water inside this and some is getting bubbled out, right? So hydrogen gas is produced here and it is collected. So this is how we get hydrogen gas from the reaction. So this is the metal. If this metal is iron, we will get 3 moles of H2 here. Got it? So this is the production of dihydrogen gas from the reactions. All right. Now, the third point is many metals are capable of displacing hydrogen from acids. Many metals are capable of displacing hydrogen from acids. So when a metal is reacting with acid, it forms dihydrogen gas and salt. So many metals, they are capable of displacing hydrogen from the acid. Clear? I will give you one example. So if I take a zinc metal and try to react it with HCl, hydrochloric acid, it will produce a dihydrogen gas and a salt. So what is the name of the salt? Zinc chloride. Zinc chloride is the salt. And if I want to go for one more metal, let me take magnesium. Magnesium is also reacting with HCl to produce MgCl2 salt, magnesium chloride salt and hydrogen gas. Okay, so these two reactions are mainly used to prepare hydrogen gas in the laboratory. Hydrogen gas in the laboratory, in the lab. Okay, if you want to prepare hydrogen in a small scale, then you can take zinc metal or magnesium metal and you can put those metals in the hydrochloric acid. Okay, it is a liquid, right? So you can put it in the hydrochloric acid, then you can get hydrogen coming out. You can collect that. Okay, so this is how we are getting hydrogen in the laboratory using these two reactions. And one more note I want to give you for this non-metal displacement. Cadmium and tin. Cadmium and tin do not react with steam but are capable of hydrogen from acid. Do not react with steam but are capable of displacing hydrogen from acids. So who are these cadmium and tin? Both of them are metal. Okay. Cadmium is a D block metal and tin is the P block metal. So these two metals, they do not react with steam. Steam means H2O in gaseous form. So no reaction will happen if you put cadmium in water. I mean in the steam. Okay. So they cannot give you hydrogen. So instead of putting this in H2O in gaseous form, put it in acid. So put cadmium inside HCl, hydrochloric acid. So if you put it and there they will produce a salt and the hydrogen gas. Okay, so these are the exceptional cases which are very important. Okay, cadmium doesn't react with water, but it reacts with HCl, acid. Cadmium doesn't react with steam, but it reacts with acid. Okay. So these are the exceptional cases. So can you able to understand? Any doubts so far? Do you have any doubt from the points that we have discussed so far in the non-metal displacement? Shall we go for the next point about this? Okay. So the next thing that we are going to discuss is halogen activity series. So what are halogens? Can anyone give me the list of halogens? It is very easy, right? Can anyone give me the list of halogens? Halogens belong to 17th group in the periodic table. Can anyone give me the list? Very good. Yes. Very good, Kartika. Fluorine, chlorine, bromine, and iodine. Exactly. Exactly, you're correct. Fluorine, chlorine, bromine, and iodine. Yeah. Very good, Chandu. So, if you look into the oxidizing power of these halogens, the fluorine will have the highest oxidizing power. Okay. So, it is a strong oxidizing agent, I can say. Fluorine is one of the strongest oxidizing agent. So, since it is having the highest oxidizing power compared to other three halogen, fluorine is capable of displacing Cl, Br and I minus. Cl minus, Br minus and I minus ions. Okay. So the displacement reactions of chlorine, bromine and iodine using fluorine are not carried out in aqueous solution. So why? Fluorine can able to displace, but they are not carried out in aqueous solution. Why? It is highly exothermic in nature. It is highly exothermic in nature. So if I take some aqueous solution, for example, if I take the aqueous solution of potassium chloride, and if I try to replace this Cl minus with F minus, the reaction will not occur. The reaction will not occur. So what I have to do, I cannot take any salt. Okay, I cannot take any salt solution. Okay, I cannot take NaCl and add F2 to get the product. So this reaction will also not occur. So fluorine cannot displace the chlorine. Okay, because it is an aqueous salt solution. So what I have to do, I can take H2O in the liquid form. H2O in the liquid state and I can make it to react with fluorine. So there fluorine can displace. There fluorine can displace the hydrogen. Okay, fluorine can displace the hydrogen. Clear? Can you all able to understand? So HF is coming out. Okay. So in the halogen activity series, fluorine is having the highest oxidizing power in which it can reduce, in which it can displace all the ions. Shanmuka Sai Ganesh, yeah. This class is there in going live in YouTube also. It is going live in YouTube also. You have joined late. Did you join late, my dear? Okay. So if you want to go through the class again, you can go to Avanti Live 2 channel and there you can get this class. Avanti Live 2. Avanti Live 2 has the recorded session of this class. Now it is going live. Okay. What I was saying, yeah, we were discussing about the halogen activity series and fluorine is having the highest oxidizing power and it can displace the other three elements, but not in aqueous form, but only with water in its liquid state. All right. Clear? Clear for all of you? So we have some more informations to be discussed about the halogen activity series and the halogens. Since we are running out of time, I am going to wrap it up the today's session here and we will discuss those things in the next class. Okay. We will discuss those things in the next class. So do you have any doubts from today's session? Do you guys have any doubts from today's class? So we are in the displacement reaction, which is the third type of reaction. Okay. We have completed metal displacement and entered into the non-metal displacement, and we are studying some points under the non-metal displacement case. Okay. So everything is clear. Okay. Thank you so much for attending the today's class, my dear students. I have launched a poll. So please give your answer for all the 5 questions given in the poll and get ready for your next class. Thank you. Bye. Take care.